All right, first question, cube root of negative 64. Can I take a cube root of a negative?
Yes.
Yes. What can't I have a root of?
Any even one.
Even. Yeah. Yeah. So cube root, fifth root, seventh root, it's okay if the negative's there. Square root, fourth root, sixth root, not okay. So the cube root of negative 64, negative 4. 81 to the 1/2. How do I write 1/2 as a root? It's just the square root of 81, right? So this is the square root of 81, which is just 9. Negative 27 to the 2/3. Okay, I would not square negative 27 and then take the cube root of it. I would take the cube root of negative 27 and then square it. Okay? Cube root, because this is how I could write this. Cube root of negative 27 is negative 3. Negative 3 squared is 9. And then 125 to the negative 1/3. What's the negative mean as an exponent? Flip it. Doesn't change the sign of anything. Just flip it. Okay, so this really is 1 over the cube root of 125, right? Which is just 1/5. Negative means flip. 1/3 means cube root. Cube root of 125 is 5. So it's 1/5.
Oh, gotcha.
All right. Next, simplify the expression of this. So when I have an exponent and I raise that number to an exponent, what do I do to the exponents? Multiply. What's 1/3 times 3? 1. So it's 3 to the first power times 4 to the first power, which is 12. Cube root of negative 8 x cubed, y cubed, z cubed. Just take it in parts. Cube root of negative 8 is negative 2. Cube root of x cubed is x, y, z, and I'm done. Okay. All right, next one. 4xy to the negative 1 over 16xy squared, the whole thing raised to the negative 1. I personally would probably simplify what's in the brackets first before I raise everything to the exponent. So to simplify that, 4 over 16 is 1/4. X over x, those cancel. Y to the negative 1 divided by y squared, I take negative 1 minus 2, right? Which is negative 3. Y to the negative 3 is the same as 1 over y cubed. So y cubed is down here. Then I raise this whole thing to the negative 1, which just means I flip the whole thing. So my answer is 4y cubed. Good there? Okay. I'll give you one of my secrets on a problem like this. If I see a problem like this on the ACT or on a test, I know the only way I can combine these two is if I have two that have root 2. They have to be like roots for me to add them. And if it's on a test or on the ACT, they won't just say no answer or this is as simplified as it gets. They're wanting you to combine like terms. So I know I'm going to have something with a root 2 here. Otherwise, I can't simplify it. Does that make sense? So if it's a root 3, then I know I'm going to have a root 3 when I simplify that one on the left. So that means, what is this number divided by 2? Is 49 a perfect square?
Yes.
Yeah. So this could be rewritten as 49 squared to 2. It saves a little time if you kind of see that pattern. Then you aren't trying to guess all the perfect squares that go into 98. If you just divide it by 2, because you know you've got to have a root 2 on the outside in order to simplify it, makes your life a lot easier. So the square root of 49 is 7 square root of 2, plus the square root of 2 is how many square roots of 2? 8. 8 square roots of 2. Questions on that? I can only add roots if they're the same root. Okay. Now we're going to look at functions. And first it's going to be f of x plus g of x. So all I do here is just add. So if I add 5x plus 3 plus 2x, combine my like terms, 7x plus 3. Now if you'll notice, if you did notice, on your review, it said find, I better see exactly what it said. Perform the indicated operation and state the domain. It's going to be the same kind of thing on your test. If you don't state the domain, you're going to miss half a point on every one of those. I'll say that again. Last year I said it 2, and everybody just did half the problem, and everybody missed half a point. And there's like 1, 2, 3, 4, 5. So automatically you're going to miss 2.5 on those 5 problems if you don't state the domain. Okay, so let's go through how to find the domain. What kind of a function is this? What does it look like in graphical form? A line. What's the domain of any line? All real numbers. Goes on forever in both directions. So if it's a line, if whatever you get combined is a line, it's all real numbers. That's your domain. Okay? And we write that like that. So that's the domain. And I might write domain, whatever, just so you know what's coming. Okay. Next one is f of x minus g of x. Well, that's 5x plus 3 minus 2x, which is just 3x plus 3. What kind of a function is that? A line. Domain of any line is all real numbers. It's not that hard to write the domain for these. Okay. Next one, f of g times g of, or f of x times g of x. I don't know why. Okay, so I have 5x plus 3 times 2x. So that becomes 10x squared plus 6x. What kind of function is that? What does it look like? Parabola. What's the domain of any parabola that opens up or down? All real numbers. The range is not, because the range you got to find the vertex. But I didn't ask for the range. I just want the domain. Domain of any parabola that opens up or down, all real numbers. Okay, f of x divided by g of x. Well, that is 5x plus 3 over 2x. Well, this is a rational function, which we haven't studied yet. But you don't need to understand rational functions to the level that we're going to get to, if we make it there, to understand how to find the domain. Because it's a rational function, it has a denominator. If you have any kind of x, a variable, in your denominator, you've got to figure out what the value of x is that makes your denominator 0. Because that function, the domain doesn't exist when the denominator is 0. It'll be anywhere else on the number line, but where the denominator is 0, this function doesn't exist, so it can't be part of the domain. So to do that, all you have to do is set your denominator equal to 0 and solve for x. X is 0. So x can't be 0. If it's 0, denominator's 0, function's undefined, doesn't exist. But there's no other number that exists that would make this function undefined other than 0. So 0 is the only one that can't be part of the domain. Okay, so I'm going to go from negative infinity to 0, union with 0 to infinity. All real numbers except 0. Make sense? Okay. Composite function, f of g of x. G of x is 2x. F of x is 5x plus 3. So to do f of g of x, I'm going to take g of x and put it in for x in f. So everywhere there's an x, I'm going to replace it with 2x. And then simplify. What kind of function is this? Line. What's the domain of any line? All real numbers, no restriction. Okay, I'm going to do an example now of a composite function that was not on the review, just to give you a little more complicated problem. I want to know the composite and its domain. So what's the composite? What do I do?
You put the square root of x minus 2 in for all of these.
Good. So you got half a point there. Okay. To find the domain of this function, there are two pieces to it. There were two pieces to the last one, but we didn't really have any restrictions on either of the functions that we were taking the composite of. This time we do. So if you're going to find the domain of a composite function, you have to identify the domain of the function that you're...
There is an Interact Club meeting in the Student Center at this time.
I'm going to take this, I'm going to find the domain of this function because this is what's going in for x. And if this function doesn't exist, I can't put it in for x. So I have to analyze the domain of the function I'm putting in. And then second, I have to analyze the domain of my final function. Okay, so let's look at the domain here. What can't be under the radical? A negative number. Okay, so the domain of this function is everywhere the radicand is greater than or equal to 0. Can it equal 0? Yeah, square root of 0 is 0. That's defined. Square root of negative 1, we know it's I, but that's not going to be on a number line. It's not a real number. It's imaginary. Okay, so we have to figure out where the domain is of the function we're putting in. And the domain's going to be all numbers greater than or equal to 2. Any number less than 2 is going to make this negative, which can't exist. Okay, so the domain of this function is just all numbers greater than or equal to 2. Okay, so we've analyzed the domain of g of x. Now we're going to analyze the domain of the composite. Okay, the only difference really, it still can't be less than negative 2 in the numerator, but the denominator can't be 0. Right? So if it's equal to 2, 2 minus 2 is 0, the square root of 0 is 0, in my denominator, undefined. So this can't be equal to 2, it has to be greater than 2. Okay? So once I found the domain of this and the domain of my actual composite function, I'm going to look at the two of them and figure out which is most stringent. And greater than 2 is more stringent than equal to 2, or greater than 2. Right? So this is my domain. X is greater than 2, which I would write like that. Parenthesis, not bracket. Does that make sense? You're just having to find the domain twice. You have to find the domain of what's going in, and then the domain of what the function was at the end.
Now, why do you not bracket 2?
Because it can't be 2. If it's 2, my denominator is 0. Okay, now, what about g of f of x?
X plus 3 over x.
Plus 2, minus 2. Okay, so the first thing I have to do is analyze the domain of this. Well, x can't be 0. There's no other restriction. It just can't be 0. Okay, so I'm going to just write that to the side here. Now I'm going to look and see where this is negative. Okay, I need x as a denominator. Did everybody see how I did that? I need to get x as a denominator. Right now, 1's my denominator of 2. So if I multiply top and bottom by x, I get 2x over x. So then I can combine my whole numerator into 1. That make sense? Okay, and this is still under the radical. So this becomes negative x plus 3 over x. No, you can't do that. No, that's like so easy, and the calculus kids are still doing that, and you can't. Okay, let me show you why. I'm going to do a sidebar. Can I just cancel the 3's? And the answer is 2.
Interruption. Just one more time. There is an Interact Club meeting in the Student Center this time. Thank you.
Mr. Hinkson, persuade me with this.
But
So it'd be 5
that's
over
a
3.
negative x.
Okay.
Positive.
Is this still equal to, well, what you cancel these, you get negative 1 plus 2 is 1. What's negative 3 plus 2? Negative 1 over 3, negative 1/3 is not equal to 1. You cannot cancel if it's combined by addition. Okay? Same is true like this. This is not equal to x plus 2. It's combined by addition. You can't just take the square root of both and call that your answer. Okay. Side note. So, I'm looking at the domain of this function. I know right away x can't be 0. But I also know that this number up here can't be negative. Negative x plus 3. Because if it's negative on top divided by x, right? Negative x plus 3 over x has to be greater than or equal to 0.
Why? So you can't be.
It can't be. That's why it's greater than or equal to. This is how I'm going to solve and figure out what x is. So x is, I multiply x by both sides to get negative x plus 3 greater than or equal to 0. Negative x is greater than or equal to negative 3. So x is less than or equal to positive 3 because I have to switch the sign. Okay, that's my domain for my composite function. X has to be less than or equal to 3. And I know it can't be 0. A lot of times I'll just draw number lines. I know it has to be less than or equal to 3, but it can't be 0. So I would write negative infinity to 0, union with 0 to 3, and I'm done. Okay, so I accounted for the domain of the original and the domain of the composite. You won't have one quite this this complicated on the test, but I definitely want you to understand the domain of square roots. You just can't be negative under the radical. Okay? All right. Let's go on to inverses. Find the inverse of 2x minus 4. What do I do to find the inverse? Yep, switch x and y and solve for y. Okay? This one didn't ask to find the domain, so you're done. Okay? Next one, I'm just going to write y in place of f of x. Same thing, right? Switch x and y. I'm going to multiply that by negative 3/2. So that becomes y equals negative 3/2 x plus 6. Questions on that one? Okay, now we want to find the inverse of this. Y equals x squared, and they give us a restriction that x has to be greater than or equal to 0. Well, the reason they give us the restriction, if you remember, it's close enough. That's y equals x squared. Does it pass a horizontal line test? No, which tells me its inverse is not a function. So I can't find the inverse of this function because the inverse of it will not be a function. So what I have to do is restrict the domain maybe to that. X is greater than or equal to 0. Then it passes the horizontal line test. So then I know the inverse of this function will also. So all this is telling you is the author of the quiz or the review knew you couldn't find the inverse if you didn't restrict the domain. So they restricted the domain for you. Okay? So if this was the original function, my new function might look like this. If I restrict the domain to just be that piece, my new function's inverse is just going to be that piece. See how it's symmetric around the line y equals x? Okay, so I'm going to switch x and y, take the square root of both sides. When I take the square root of both sides, I have to remember the plus or minus. Well, this is the plus, this piece is the minus. So I know, because they restricted the domain, that I can't have the minus part of it. Okay, so my answer is just positive square root of x, not plus or minus. Okay. All right, graphing. Well, this just takes the square root of x and does what? Shifts it up 1. So my new graph, something like that. I would get it more precise if I were taking a test, but all you do is you take the square root of x graph and shift it up 1. Okay. Next one. Well, you need to know the parent function of the cube root. 2, 3, 4, 5, 6, 7, 8. 2, 1, 2, 3, 4, 5, 6, 7, 8, negative 2. That's what the cube root of x looks like. We're also supposed to state the domain and range. I better go back and do that one for this one. What's the domain of this final graph? 0 to infinity. What's the range? 1 to infinity. Okay. All right, so what I'm going to do first is account for the 2. What does the 2 do to the graph, the look of the graph? It stretches it by a factor of 2. So every y value, I'm going to multiply it by a factor of 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. So when I connect this, do you see how it stretched it up and down? It's now stretched by a factor of 2. Okay, so now I've taken care of this piece. But now I've got to shift everything down 3 units. Okay? So this point goes down 3. 1, 2, 3. This point goes down 3. This point goes down 3. 1, 2, 3. 1, 2, 3. There's my final graph. Something like that. Just shift it down 3. What's the domain? All real numbers. Yep, negative infinity to infinity. What's the range? All real numbers, negative infinity to infinity, because it's a cube root graph. Okay, so just start with the parent graph. All you need to remember is 2 of them, the square root of x graph and the cube root of x graph. And then just follow the instructions and what it tells you and shift it. That's why we did so many practice problems in web work, to be able to recognize what those transformations are. If it were a negative in front, all these numbers would just be flipped over the y-axis, or the x-axis. I won't give you any that are flipped over the y. All right, last one on the graphing ones. Take the graph of the square root of x, 2, 4, 2, and shift it where? Right 7. If it's under the radical, it's a shift left and right, and it's always the opposite of what you think, right? Because the general function is, so if h is positive, meaning a right shift, it's going to be x minus h. H is negative, meaning a left shift, it's going to be x plus h. Okay, so it's a shift right 7. 1, 2, 3, 4, 5, 6, 7. 1, 1, 2, 3, 4, 2. And there it is shifted. That's it. What's the domain of this function? 7 to infinity, including 7. What's the range? 0 to infinity, including 0. Okay, it's so much easier to do the domain and range after you've graphed it, because then you can just see it. All right. The last few are solving equations with radicals in them. So how do I undo a cube root?
You
Cube it. Cube both sides. The cube root of 2x cubed is 2x. 4 cubed is 64. And then just check it. 2 times 32 is 64. The cube root of 64 is 4. Check. Okay, next one. Okay, how do I undo a square root? Square both sides. Okay, subtract x. And then check it. 3 times 3 is 9. The square root of 9 is 3. 3 plus 6 is 9. The square root of 9 is 3. Check. Okay. going to do the last one on the review, and then I'm going to do one a little more complicated, just to make sure you all know how to do those kinds. And then we will be done. This is a minus 3. Equals 3. How do I undo? Square both sides. Subtract 9. How does that factor?
X minus 4 X plus 4.
So x is either negative 4 or positive 3. I need to check both. If it's negative 4 squared is 16, minus 4 is 12, minus 3 is 9. The square root of 9 is 3. 3 squared is 9, plus 3 is 12, minus 3 is 9. The square root of 9 is 3. They both work. What's that?
No extremes.
No extraneous. They're both good. Okay. For both sides. This side's easy. Right? Trick question. Okay. Yep, so you square both sides. Square this side, that becomes this. Square this, positive 4. That there's the middle term. And the middle term is this times 2. Negative 4 square root of x plus 4. Now I've got to isolate this root. These x's cancel, right? If I subtract x to either side, it's just going to 0. So I have plus 4 plus 4. So I have negative 4 square root of x plus 4 plus 8 equals x plus 3. Oh yeah, thank you. 3. I'm going to subtract 8. I'm going to divide both sides by negative 1 because I recognize if I divide both sides by 4, I'm going to end up with a fraction on the right. I'm just going to go as far as I can without fractions. Okay? So at this point, I'm going to square both sides. And when I do it this way, I have to remember to square the 4. So 16 times x plus 4 equals 25. So that's 16x plus 64 equals 25. 16x equals 25 minus 64, 39. Is that right? Okay. And then divided by 16. So x is equal to negative 39/16. That's really ugly. But it's what happens when I make a problem up on the fly. So we're going to go back in. Negative 39 over 16. What is negative 39 over 16? Someone with a calculator do this. Plus 4. Okay, square root. Minus 2.
Negative 0.75.
Okay, what is negative 39 over 16 plus 3?
9 over 16,
Square root.
0.75.
Okay.
I might have.
No, you're right. So I have negative 0.75 equals 0.75.
It's wrong.
It's wrong. Doesn't work. No solution to this problem. The only answer we got is extraneous. You have to check it. If you did all this work and you got that answer of negative 39 over 16, I'll give you 3/4 of a point. But if you didn't go back and check it and tell me there's really no solution to this problem, then you won't get that last quarter. Okay. Questions on material in this chapter? Okay. That is it then. Test is tomorrow. We'll start in on chapter 8 on Wednesday. I believe logarithms.
Ooh, we're finally getting into that.
Mm-hmm. Rational functions are our last chapter, and I don't think we'll get there.
Are we ever going to see? Wait, what are we doing this chapter 8? Logarithms.
Yeah, I can show it to you, but I can't. You haven't finished it.
There's one logarithm question.
Let me stop this.